Lesson 3 of Chapter 10 is on geometric sequences and series. Our last lesson, Lesson 10.2, was on arithmetic sequences and series. The difference between arithmetic versus geometric sequences is that arithmetic has a common difference. It goes up by the same amount each time or goes down by the same amount each time. With geometric, there's not a common difference but a common ratio, meaning you're going to be multiplying by the same value to get the next term. So here is a formula that you'll use to come up with the explicit formula on how you find the nth term. As an example, if I just give you a real basic geometric sequence, you can see here that the common ratio is 3, then your explicit formula would be by taking the first term, multiplying by the common ratio raised to the n minus 1. Fairly simple formula to use. This problem says find the specified term of each geometric sequence or sequence with the given characteristics. So they want us to find the 9th term and they give us the sequence. So our first step is to find the common ratio. Well, the ratio can be found by taking the second term and dividing by the first. So you can see here that our common ratio is 7/2. Then our explicit formula would be found by taking the first term times the common ratio raised to the n minus 1. And now, to find the 9th term, we simply put 9 in for n, and then I'll use my calculator to get that value. And we get 90,075. .01563. So that's the value of our 9th term. Next problem wants us to find the 12th term. This time it doesn't give us the first term. It gives us the third term is 32 and the common ratio is -4. Well, if it helps to try to find that first term, what you can do is you can work backwards. You can see that the third term is 32, so the previous term would have to be -8, because what's -8 times -4? It's positive 32. Which means that our first term would be positive 2, because if you take 2 times -4, you get -8. So now with that being said, we can come up with the explicit formula, and that would be found by taking the first term times the common ratio raised to the n minus 1. And now finding the 12th term is pretty simple just by putting 12 into the formula. And that gives us -8,388,000. And 608. So you can see on the left-hand side we have a couple of geometric sequences, and on the right-hand side we've got a couple of geometric series. The difference between a sequence and a series is simply your list of numbers separated by commas versus addition. And then at the very bottom you can see we've got our subscripts. We got A1, which represents your first term, A2, A3, A4. AN represents your nth term. So if you have to find the sum of a finite geometric series, we've got 2 formulas you can use. Here's the first formula, and there's really 3 things that you need to use that formula. The first thing is you got to have the value of the first term, A1. You need to have R, which is the common ratio, and you need to know how many terms you're adding up, which is n. We have a different formula right here that sometimes is beneficial. And to use that formula, we also need 3 things. Again, we need A1, the first term. We would need R, the common ratio. And we would need AN, which is the value of our last term. So if you don't know how many terms you're adding up, but you know your last term, I'd use the formula circled in green. So here's an example. It says find the sum of the first 6 terms of the geometric series. So coming up with that, we're going to be using this blue formula right here. So we got to have the first term, which you can see is 8. And then on the bottom, you can see it says 1 minus r. And our common ratio is found by taking the second term and dividing by the first. So our common ratio is 7/4. And the top is 1 minus r to the n, which in this case is 6. So now if I go to my calculator and enter that, one minus 7/4 on the bottom. On the top, we get 1 minus 7/4, and that has to be raised to the 6th. And we get 37,851 over 128. That's the sum of your first 6 terms. If you wanted to get it as a decimal, you could simply change it into a decimal like this. By doing that problem reminds me of one of my favorite jokes. A gal goes into a bar and she sees a guy sitting at the bar, and she starts talking to him. And the guy happens to be a mathematician, and she says, "How old do you think I am?" And the mathematician says, "Well, judging by the fire in your eyes, you look 18. Judging by the glow in your cheeks, you look 19. And judging by the radiance of your face, you look 20. And adding those all up is probably something you can do on your own." Next example. Find the sum of the first n terms of the geometric series. This time it tells us our first term is 3. Our last term is 768. That's what this is saying. And the common ratio is -2. So this is an example where we want to use this green formula right down here. So we don't know how many terms we're adding up. And so the formula says to take the first term, subtract the last term times r. We can see our first term is 3. Subtract your last term, 768 times r. So there's your numerator. And then on the bottom we have 1 minus r, which in this case is 1 minus a -2. So if we do that, we get our numerator to be 1539. Our denominator would be 1 plus 2, which is 3. So if we divide that by 3, we get 513. Next, we've got a sigma notation, and this is geometric. And how I know that is based upon the formula that I'm seeing here. I can see that the common ratio is 5. Well, the number of terms that we have here is 7 minus 2 is 5, plus 1 is 6. We're going to have 6 terms. I'm going to list all 6 of these terms here. We start off by putting 2 in for n, and if we do that, we're going to get 3 times 5 to the first, which is 15. Then we're going to put 3 in for n, and we're going to get 3 times 5 to the second, which is 75. And what you're noticing here is we're just multiplying by 5. So 75 times 5 gives us the 375. You get that by putting 4 in for n, times 5 gives us 1875. Putting in 5, 9375. Get that by putting in 6, and then our last value, 46,875. You get that by putting 7 in for n. And now adding them all up is what we're trying to do, so I'm going to use the formula. Sum of these 6 terms would be found by taking your first term, 15. Bottom is 1 minus r, and our r value is 5. The top is 1 minus r raised to the n, and we're adding up 6 terms. So if I do that now in my calculator, 15 times, bottom is 1 minus 5, the top is 1 minus 5 raised to the 6th. And that gives us a total of 58,590. Lastly, I want to go over this formula right here. This formula is a really simple, basic formula to use. We use it when we are finding the sum of an infinite geometric series. There is an important caveat to using this formula, though. The sum can only be found if the absolute value of r is less than 1. So your ratio has to be in between -1 and +1 is what that's saying. So here's an example. It says, find the sum, if possible, of this infinite geometric series. Well, hopefully you can tell that the r is 1/3. And since the absolute value of 1/3 is less than 1, we can use the sum formula. The sum formula says to take the first term and just divide by 1 minus r. So if we take the first term, 9, and divide by 1 minus 1/3, this will give us 9 over 2/3, which is the same thing as 9 times 3 over 2, which gives us 27 over 2, or 13.5. And if you think about it, the first 2 terms add up to give you 12. The first 3 terms add up to give you 13. The first 4 terms would add up to give you 13 1/3, and those are going to continue to get closer and closer to this value right here, 13.5. Same directions on the next problem. It says, if possible, the infinite geometric series. Well, we start off by finding the common ratio. And the common ratio is found by taking the second term and dividing by the first term. And you can see here that gives us a -5 for a ratio. Well, the stipulation was the absolute value of r has to be less than 1. And since the absolute value of -5 is not less than 1, we cannot find the sum of this. It does not exist. So that's why the directions it said, if possible. So this is a summary of geometric sequences and series and finding the sums of a geometric series, whether it be infinite or finite.